Hello and welcome back to Cartesian. We are back again on effect of parameters on a straight line function. Before I go in, don't forget to subscribe, comment and like this video and share with your peers. Okay, so in the past videos we learned how to mathematically express ourselves, but now let's see if we can be able to read the encoded message, because I told you this is all about coding. So now we know that we have a straight line function which is defined by y is equals to mx plus c. So now we want to see the effects of this component, which is your c component, on the function. What does this c tell us? What's the message coded by this c component? So the c component tells you about the vertical elevation. Elevation from what? With functions, everything is drawn based on a Cartesian plane and is in reference to the origin. So this will be your Cartesian plane and this will be your origin, where x is 0 and y is 0. So when we talk of elevation, we talk in reference to this point as to how high above the origin is your function, or how low below the origin is your function, right? So now let's look at the effect of this component in terms of a function itself. So we're going to make a simple example so that we can graphically represent our graphs and visualize what we're talking about. So now let's say we have a simple function, but we're going to give it different values of c for variance so that we can see the effects on it. So we're going to take a scenario where c is equals to 0 and c is greater than 1, 0, sorry, and c is less than 0. So we will investigate this with the same function, not same function, similar function, but different c components. So for this one, let's take a different marker. We're going to have a function where, let me put this in a table. For this, our function will be y is equals to, we're taking a gradient where gradient is 1, gradient is 1 and m is equals to, gradient is 1 and we have x plus 0. Here gradient is still 1, but we said c is greater than 0, so let's say plus 1. We said c is less than 0, we're going to have y is equals to minus 1. So that's what we have done with our function. So this one, basically you're going to end up with y, actually let me write it right. You're going to end, because c is 0, you're going to end up with x, y is equals to x. Yeah, so these are our functions. As you can see, the m is constant. If a coefficient of a variable is 1, you don't need to show it. So basically we're going to have functions like y is equals to x, y is equals to x plus 1, y is equals to x minus 1. And then we want to graphically show this on a Cartesian plane so that we'll be able to understand what exactly does this c do to the function if there is variance in c. Let me draw a vector set here. So we're going to have our Cartesian plane like this, and we're going to have our y, positive y's, and we're going to have our negative y's, and we're going to have our positive x's and our negative x's up to infinity, and then we're going to have our origin. So now the question is, what we want to plot this function of x is equals to y is equals to x. So we want both values to be equal, which means y is equals to x. So what do we know about the origin? At the origin, x is equals to 0 and y is equals to 0. So that means this function somehow have a coordinate here, right? Because both parameters are the same. So this will be our function of x is equals to y. And we have another function of x plus 1, which means on top of x, in order for you to get the value of y, you add 1 into the value of x. So let me make marks on this Cartesian plane. In the value of x, you add 1 to get the value of y. I think you've done this method, the table method, when you in your class with your teacher. Oh, I don't know, where you have something like you'll be having the x values and the y values, and you will have your function here. Let me put this x plus 1, and you will say if I put my x, let's say my x is 1, for me to get my y, I will have to say 1 plus 1, and I will say my y is 1 plus 1, then I know that my y is 2. Something like this. I'm not sure if you've done it, but if you haven't done it, please indicate on the comment section, so that I do a video in this method, so that you will understand how we get coordinates of these functions. But I assume I'm talking to grade 9, 10 and 11 students who know actually this method of plotting coordinates based on the function. But if you don't know, just indicate there. I will make another video on this. But let me go back to the point that I want to make with this video. Leave this part. So we want to plot this graph. So our value of y will be x plus 1. If our x is 1 here, I will say 1 plus 1, which is 2. That means my y coordinate is 2. So for this, let me use a different marker. For this, my function will be a 2 around here, right? So which means, sorry, for a x coordinate will be 1, and a 2 here for a y coordinate, right? So this function cuts the x-axis at this component, which is a plus 1. Even look at it, it says plus 1 here. So from the origin, you move 1 unit up. So that means this function crosses around here. And we're going to have this function where we have a minus 1. A minus 1, which means from your x coordinate, you minus 1 unit, then you can get your y coordinate. And then that means, let me use a black marker. That means that function cuts your y here. This is a negative 1. Cuts your y here. So this will be your function. So this function will be y is equals to x minus 1, and this one will be this one will be y is equals to x plus 1. So you get to see that from all these functions, looking at the graphical representation here, let me zoom. Looking at the graphical representation of these functions have the same gradient, which is your m. Your m is kept constant at 1. And you have the same, I'm going to say you have the different c components. So it's showing you that if this was the graph, now it moved a step above. If this is the graph, the moment I say plus 1, it moves a step above the origin. And the moment I say minus 1, it moves a step below the origin. So that is what we mean when we talk about the vertical elevation of the graph. So in the next video, I will make a video where I actually explain this component with real life situations, so that you understand how this function, this component affects the graph. So I hope you understood. Don't forget to comment, subscribe and like this video, and ask questions if there's something you don't understand. And yeah, if you want me to show you how I did that method of plotting the graph, don't forget to comment and I will do so. For now, I'm signing out. Bye bye.